Hello and welcome once again to Talk My Car, where we make cars talk to you in a language only they understand. Please note that we have a Facebook group forum where we discuss issues related to, especially to engine and gearbox control management by computers in modern cars. The URL is at the bottom of the screen here. The cursor highlights for you. My name is Ivan, and today we are going to have a chat about GDI and VVT system operation. There are a lot of misconceptions out there in the field and amongst vehicle users and owners as to what these two, how do they operate, and some people actually mistake one for the other, GDI for VVT, which is not the case. GDI stands for gasoline direct injection, and VVT stands for variable valve timing. Now these are separate things on the vehicles. Some people believe when you have one on the car you can't have the other, which is not true. You can have, it's possible to have a vehicle with both types of systems, engine management systems. Now, briefly, GDI is usually associated with Mitsubishi vehicles, but other manufacturers have developed similar systems with different names, as I will show you later. But most commonly for Toyota, D4 is the equivalent for Toyota. It's the equivalent of GDI in labeling on Mitsubishis. But GDI is similar in operation to most modern diesel engine management systems, as I explain now. What you basically have with a GDI or any diesel high pressure system on most diesel vehicles after about 2002 and onwards, the main peculiarity with these engines, the main peculiarity with this type of engines is a high pressure pump on the engine. For most vehicles in the past, at least the gasoline ones, you had a fuel pump in the fuel tank, usually in the fuel tank, that would send fuel at relatively low pressure all the way to the injectors on the engine. Now, in the GDI way of things, on top of that low fuel pressure pump in the tank, you have a high pressure pump on the engine. Now, that is this unit here. This unit is mechanical in how it makes pressure. In here is low fuel pressure from the tank, from the low fuel pressure pump in the tank, and out here goes the high fuel pressure heading now to the fuel rail. But how this pump increases or multiplies that pressure is is simply mechanical in operation. You have this plunger down here being operated, pushed in and out by a camshaft, a lobe on the camshaft. So as the engine rotates, one particular cam keeps pushing it up and down, and it's simply mechanical. In here is simply making pressure out of these pushes that's receiving from the cam. Now, the clever bit of this whole arrangement is this guy here, the pressure relief valve. It's a solenoid type of valve with two wires. Basically, it receives 12 volts and it's grounded through the computer. So through duty cycle pulses on the ground side of its circuit, the computer is able to relieve the pressure, because as you increase RPM on the engine, you're going to have many more rotations in that direction. You have the cam pushing more times on this plunger, and you have increased pressure. Now the ECM desires to maintain a specific pressure in the fuel rail, so it will use this pressure relief valve to bleed off any excess pressure beyond that which the ECM desires in the high fuel pressure rail, and it will close it if that pressure is lower than desires, and it will let this plunger and pump build the pressure up again. So it's a very fast operation going on, and that's why you notice that on most vehicles with GDI and D4 type of fuel delivery systems, you have a separate injector driver, which at the same time operates this pressure relief valve and oversees the whole pressure build up, high pressure build up side of the engine, of the fuel in the engine. Now here is the cam I was talking about. This cam will typically be on the camshaft, and as it rotates, you see this side is longer, this side is shorter. So when this shorter side is in contact with the plunger will come out some more. When this side approaches, it pushes the plunger back in, so you have that back and up and down type of motion, which will translate mechanically into pressure building up on this side. Up here you have low fuel pressure entering here and high fuel pressure fuel going out, and this is the connection once again to our pressure relief valve. Any fuel bled off by this valve returns to this low pressure fuel side. Now here we have more components of the system. Thrown into the mix now is this guy here typically with three wires. That's a pressure sensor, fuel rail pressure sensor. The job of that guy is to tell the ECM, to report back to the ECM what the pressure in the fuel rail, which is this unit here, and what you get is because the ECM now has the information, it observes when pressure is going beyond the limits that it requires. It will now command through the injector driver, it will command this valve to open. If the pressure in here is too low, it will command this valve to close and then wait until this pump mechanically increases the pressure in the fuel rail before and this guy will be reporting everything that's happening to the ECM, and then the ECM will once again command this guy to open using duty cycle signals. So that way the ECM can very neatly control the pressure in the fuel rail here. On most diesel engines at least, and some gasoline ones, the pressure in this fuel rail can go as high as almost 3000 psi. That's very high pressure, and for that reason the injectors on the GDI type of engines work in similar fashion to the common EFI type of injectors, but they are more powerful, and these tips of theirs have to withstand much higher temperatures, because in EFI system these injectors deliver the fuel into the intake manifold for it to be mixed with the air. Now with GDI engines, the fuel is delivered straight to the engine cylinders direct. It doesn't go through the manifold. Only air goes through the intake manifold on its way to the engine cylinders. So because these injectors have to deliver the fuel right into the cylinder, the hot cylinder, they are made out of special materials, and they have to withstand that temperature for very long times, and they withstand very high pressures, and they work very quickly, because the injector operation times for EFI and for GDI are very different. The ones for EFI are much longer than the ones for GDI. The ones for GDI have to operate in a very short window during the compression stroke, whereas the EFI injectors have the entire the entire intake stroke duration, and sometimes they can be fired even beyond that, even during the exhaust stroke. And because their goal is to have the fuel mixed with the air going into the cylinder, they have a longer period. The EFI type of injectors have a longer period during which they can deliver the fuel, but the GDI type of injectors don't have that luxury. They operate through the injection pulses take a very short time, but the beauty with it is these injectors are so fast they can be fired twice or even more times during any compression stroke. They are that fast, and to operate the entire arrangement requires a lot of computing power. That's why once again you will notice that these vehicles have a separate injector driver unit, separate from the computer. The ECM or the computer exports those calculations and functions to the injector driver. What we have now on the screen is a little bit of the graphical schematic kind of representation of the basics of a common type of high fuel pressure pump. So when this solenoid is controlled by the ECM, it has a pinto in here that it moves in and out depending on the duty cycle of the that's being applied by the injector driver to relieve high fuel pressure back into the return, or to stop it altogether. So basically this is low fuel pressure in, high fuel pressure out, but when this closes you don't have fuel returning that way. I hope you've got the gist or the basics of how GDI or high pressure injection engines work. Different manufacturers have different names for this type of system, so don't be surprised by or rather don't get caught out when you see these labels on vehicles. They more or less all mean the same thing, just depends on the manufacturer. What it all boils down to is high fuel pressure systems being installed on the vehicles, and the manufacturers want to label their vehicles to show how special they are, how advanced they are from previous technology, but they all use different names again to try to stand out from the crowd, but it's basically all the same thing. You can pause the video if you wish to take a closer look at the list. Otherwise, we now move on to explanation of how VVT works. VVT stands for variable valve timing. You have additional letters added like I, that means intelligence usually, E means electronic, and things like that. Now, how does it work? Or rather, what's the point of varying the valve timing? On the camshaft, which control especially the intake valves, and on some models the exhaust valves as well. When you have the old type of cam timing, you have an engine with valves timed at the same positions all the time, at all speeds, at all RPMs. Now, think about this. When the engine is idling, it doesn't require a lot of air. As the RPMs rise, it is going to ingest much more air now. It will require much more air, and because the timing is not changing, higher RPMs means the valves are open for shorter times overall, because the engine is faster, is running faster. So the question is, how much air is getting into the engine at high RPM versus what amount of air does it require? Because at higher RPMs, the times for the durations for which the valves are opening is shorter, yet the engine requires more air to generate more power at higher RPMs. You see the problem now? So in the past, you'd have engines operating at their most efficient at a certain RPM. Below and above that, they wouldn't be that efficient because of the times for which the valves were opening were not effective in terms of efficiency, were not very effective in letting the engines ingest the required amounts of air. So engineers came up with an engineer's plan. They thought to themselves, well, what if we could, as the RPMs rose, what if we could, in relation, vary to valve opening times, increase the times for all the duration for which the valves remain open. So now what they did is to come up with several systems. They have inherently different ways of how they work, but the goal is the same: increase valve lifting duration. Some only play around with the lifting duration. Some play around with the magnitude of the lift as well, because the magnitude increases the amount of air going into the engine. So manufacturers like Honda with their VTEC systems can play around with both the duration and the amount of lift. Toyota only tackle the duration bit and not the lift itself. And some do it on usually the intake side or valves, and others like BMW do it on both the intake and exhaust valve. Ultimately, the goal is to increase air intake, increase engine power and efficiency at different RPMs throughout. So basically they came up with ingenious plans, but all related to having a unit like this being operated either hydraulically, meaning the computer controls it indirectly through oil pressure, or directly through an electric motor to engage this guy here who is on the camshaft, speed him up, push him forward, push him back a bit, and the result will be as this camshaft rotates, if you begin trying to hold it back from its normal unloaded position, you would kind of be retarding the position at which the valves will be opening, and if you push it forward, you'd be kind of advancing the position of the camshaft, otherwise at which the valves will be opening. So basically you have some type of system, could be hydraulic, could be electrically operated, advancing or retarding the camshaft rotation. And you have a camshaft on this side, so monitoring everything during normal conditions like idling. It wants to see what you'd call normal timing. When the computer commands this guy to retard the timing, this guy here, the camshaft position sensor, camshaft position sensor is watching. It wants to see a change that depends on how much this guy has been commanded. It wants to see a change in timing. Otherwise you will get a VVT related code if the system is not functioning properly. Basically it looks that simple in operation, but usually for most manufacturer design, the details of how it works are more complicated, but mechanically, in simple terms, you are simply retarding and advancing valve opening times to get more pressure and efficiency, rather to get more power and efficiency out of the engine. So as you can see, T is different from GDI. So don't let guys on the street confuse you. If they don't understand the things, just show them this video, and maybe they will become wiser. And This image is again just an illustration of basically how VVT is controlled in a Toyota Lexus, but it gives you more or less an idea of how VVT works. Now you see these connectors here, 3 wires on this side, mean there's some kind of position sensor in there. These 2 wires are for operating the motor in there that retards or advances the timing of this entire camshaft, and therefore the openings and closing times of the valves. And then on this end you have this reluctor that keeps rotating past this cam sensor, which tells the ECM the position of the engine or this particular camshaft. I hope that is clear now. On systems that use electric motors to operate the VVT system, on top of these guys, this crank position sensor and a camshaft position sensor, here you have an EDU, electronic driver unit, just like we had one for the GDI systems. You have one, this is the ECM. It would export some of these calculations of retardation and advancing of the camshaft. It would export some of those calculations to this guy here, the VVT EDU, VVT electronic driver unit. And in here you have an electric motor that would run on 12 volts to actuate and get VVTI to operate as desired by the ECM. Do you see the difference? This is from a Lexus vehicle. This is an electronically controlled side of the intake cam side, and this is a hydraulically controlled unit for the exhaust side of the cam of the valves on the engine. Now VVTI is hydraulically controlled. VVTIE is directly electronically controlled here by the computer and EDU, by the ECM and EDU. But in this case they used both technologies on the engine, electric and hydraulically controlled, one on the intake, one on the exhaust side of the engine. Again, different manufacturers call their systems different names, but ultimately they all try to do the same thing. Don't be tricked by the names. It's so similar in operation. The goal is the same. The degree of success might vary depending on the technology, the details of the technology used, but the goal is the same. So what VTEC means on a Honda is what CVVT means on a Renault or a Citroen. What AVCS means on a Subaru is what VVTI means on a Toyota vehicle. Once again, for more details or engaging forums, please follow this URL. We have a forum where we discuss these more technical details of how vehicles work, and you can offer us some guidance, you can advise us, and you can request us for help, access to wiring diagrams, if you need computerized vehicle diagnosis, etc. Please visit us at that URL. And you can call us on that number or visit us at SSK Motor Garage in Chalwajala. At Talk to My Car, T2MC stands for Talk to My Car. We try to save you time, money, and headaches. Please avoid guesswork. Modern vehicles and how they work is really technical stuff. Don't do guesswork on your vehicles. Don't take your vehicles to guesswork mechanics. And if you're a mechanic listening or watching this, please stop doing guesswork on vehicles. Some of you actually know these things better than us, so that's very good. But for those that don't and are still using guesswork to fix people's cars, please don't. Just give us a call and we shall bring you up to speed with what we know. We don't know everything, but what we know we try to share. Thank you very much for your time, for sparing your time to watch this video. Once again, from the team at Talk to My Car, this is to wish you a good day. Thank you. Bye.